differentiating trig then. So if we have y equals sine x, when we differentiate that, we get cos x. If y is cos x, when we differentiate that, we get minus sine x. You have to learn these two, okay? Now for the other trig ones, they're all in the formula booklet, and when you're doing any differentiation or integration questions, if you open your green formula booklet to the middle pages, it's got everything that you need to know. So we'll have to learn those two, and then the other ones, y equals tan x, differentiate tan, we get sec squared x. Y equals cosec x, differentiate that, we get minus cosec x cot x. Y equals sec x, differentiate that, we get sec x tan x. And y equals cot x, dy by dx, minus cosec squared x. So all the ones in blue are in your formula booklet. The top two are the ones that you have to learn. Our examples then. So our first one, y equals sine 3x. So to differentiate that, well, to differentiate sine 3x, we would get cos 3x, and then we'll have to differentiate the x part. So differentiate 3x, we get 3. Second one, y equals sine squared x. First thing to do is to write that as sine x all squared, and then we differentiate it the same way as we did with other brackets. So it's 2 times sine x, take 1 away, to the power of 1, and then differentiate what's inside the bracket. So differentiate sine x, we get cos x. Now you would write that then as 2 sine x cos x. Our third one, y equals the cos of 4x minus 3. So when we differentiate that, differentiate cos, you get minus sine. So the minus the sine of 4x minus 3, and then we'll have to differentiate this part here. So differentiate that, and we get 4. Our fourth one, y equals cos cubed x, and again write that as y equals cos x all cubed. So when we differentiate, we get 3 cos x all squared, and then differentiate what's in the bracket. So differentiate cos x, and we get minus sine x, and then to tidy that up, we'll bring the minus out to the front and write something like that. Our fifth one then, y equals x tan 2x. Now this is a product, so that's our u and our v. So we'll have to use the product rule then. So x times the differential of tan 2x. So the differential of tan 2x is sec squared 2x. Then differentiate the 2x bit, and we get 2 plus tan 2x, and then we differentiate x, and we get 1. And then just tidying that up, we would write it as 2x sec squared 2x tan 2x. Number 6 then, y equals tan to the power of 4x. Again, write it as tan x all to the power of 4. So when we differentiate, we get 4 tan x cubed, and then when we differentiate what's in the bracket, differentiate tan, we get sec squared x. And again, I would write that as 5 tan cubed x sec squared x. Number 7, y equals sec cubed x. So again, write that as sec x all cubed. So when we differentiate, we get 3 times sec x squared. And then we have to differentiate sec x, which is sec x tan x. And then just simplifying that, we've got sec squared and a sec, so that would be sec cubed x tan x. Number 8, y equals cosec 2x over x squared. So this is quotient. So we use our quotient rule. So dy by dx is going to be x squared times differential of cosec 2x. So the differential of cosec x is minus cosec x cot x. So the differential of cosec 2x is minus cosec 2x cot 2x. And then we'll have to differentiate the x part. So we get a 2 minus our cosec 2x times, we'll differentiate the bottom and get 2x over x squared all squared. I wouldn't worry too much about how much you tidy this up. I would just take the minus 2 out. And I would put the 2x in front of the cosec 2x and would write our x as x to the power of 4. You could then cancel an x in each of the terms then. So we'd have cubed here, that x would disappear, and that would just become an x there. Okay, so these questions again can bring in other things that you're supposed to be able to differentiate, like e to the x. And again, this is a product. So that's our u and our v. So e to the x times differentiate sine, and we get cos, plus sine x times the differential of e to the x, which is just e to the x. And the only thing I would do to tidy that up is take the e to the x out. And we're left with cos x plus sine x in the bracket. And our last one then, y equals ln x over sine x. Again, this quotient rule that we're looking for here. So dy by dx equals sine x times differentiate ln x, we get 1 over x, minus ln x times differentiate sine, we get cos over sine x all squared. And again, I wouldn't really do much to tidy this up, but maybe bring that to the front. And write our sine x all squared is sine squared x.